overseas somewhere, I might still want to allow that, but based on that employee and what they're supposed to be doing, they shouldn't be calling overseas. So I can look up that data rate, and it's all dynamic. I don't have to program every single number and assign configurations to people specifically. I can just limit based on the database. Okay, what's the call rate limit? 3 cents a minute or whatever, and just limit it all dynamic that way. And then I can always increase that in the database, and that's immediately available. The next time they place a call, they are going to have that ability to place the call overseas. So yeah, and then basically using keeping our Asterisk system in sync with other systems. Okay, so as we start growing, we might have to start replicating our database to keep our data redundant, and just because we're relying on the database so much more. So we can start replicating the database by having 2 physical systems that are each containing the database. Our topology doesn't really change very much. All we're doing is just replicating the data and just making it a little safer. So we can start performing some load balancing, especially if we're doing a lot of calls to the database. Although I've never run into a situation where the database couldn't handle all the calls. And I was doing where each phone call into the system was writing information into the database, which is typically more load-bearing than just doing a simple select statement. And every step of the call, which is essentially what CEL does, but every step of the call in the dial plan, I'm writing information saying they pressed this number, they're calling this person, they called from this location, it's this time, and I'm writing all these logs into the database so that at the end of the month they can take all this information and compile essentially a bill for all these customers. How long was the call? At the end of the call when they hang up, I write all that information in the database. So I could be using CDRs to pull that information, but it wasn't quite granular enough for them. So by writing functions into and writing using FuncoDBC to write that information into the database, they're able to get a lot more information. Now, well, with Asterisk 1.8, that's essentially what channel event logging, or CEL, is meant to do, is to write that information in a more granular manner. While it's more complex, it does give you a lot more information. So depending on what you need, you might add that complexity, but at the same time get all the information you need throughout the call, as opposed to call started at this time, call ended at that time. So with the replication, I was using MySQL. It's fairly easy to set up the replication. I found a couple websites that tell you how to do it, and it's been running great for that customer for several months now. So I haven't really had to touch it at all. So now we get into a more distributed system here, where we have multiple Asterisk systems. They're connected to our replicated database. We have our web interface still. We're sending calls from the ITSP between the systems. We're using something called OpenAIS to make sure that the phones over on the system on the left-hand side and the phones over on the right-hand side there know what's kind of going on and what the state of those phones are. OpenAIS is going to allow us to distribute the device state, which is very handy in a queue situation, by having a call coming into the system on the left through the PRIs. There might be a queue running on that system, say the sales queue or whatever, and that call then is still distributed to all the phones in the company. Maybe these are they have different skill sets and everything, or we just have so many phones and so many seats, we just have to have 2 Asterisk systems. But the queue is now able to determine whether that person over on the system on the right-hand side is available or not, so that you're not getting duplicate calls to the queue members, or having to actually call them and get busy, and then they have to enter back in the dial plan, and then the queue has to keep trying people, and it's like, okay, you're busy, you're busy, you're busy. Basically keep knocking on the door. We don't have to do that. We can just look up through our database or through our system here what the state of the phone is and whether we're going to send a call to them or not. So now, this gives us the ability that people can log into queues across the cluster. We can have, say, a set of queues on system 1 and a different set of queues on the other system, and the phones can then be just put into the system, and we just send the calls wherever they need to go using local channels or whatever the case may be. The problem with OpenAIS is that it works only over low latency links. So we can't, in this situation, we can't have these Asterisk systems in different physical locations. They all have to be essentially on the same LAN. OpenAIS was available starting in 1.6.1, works very well. There's some documentation to get it set up in the doc directory of Asterisk, and it really doesn't take all that long to get all set up. So pretty straightforward, just the limitation of it being limited to essentially a single physical system. However, with Asterisk 1.8, we have the ability now to distribute device state using XMPP, which gets rid of the limitation of being at the same physical location. We can now distribute these Asterisk systems into different physical locations. We have essentially the same setup as before. In this scenario, we've removed the PRI entirely. We've moved to SIP as our only system option. But each of these systems could have PRIs, or we could have another system, perhaps another Asterisk system, that its sole job is to take a PRI in or multiple PRIs in and distribute that call over SIP to our different physical locations. So we can have all our PRIs aggregated in a single location, but have lots of different offices and take all those calls in and out over SIP, over the internet, or whatever the case may be. So now we have a single system. Even in the situation where you might have two Asterisk systems and they're duplicated, and you just have one up and the other one is hot swap, and this one dies and we fail over to this system over here, now we don't have to physically go and move a PRI line from one system to another. Yeah, you could use EEX if you want. And that would be a good situation is if we're sending a lot of calls between these two physical systems, or in the case of having the PRI and it's sending the call between the systems, we can reduce bandwidth by using EEX, because we can use EEX trunking, which is going to reduce the amount of overhead to send each of the calls. We essentially have one header and lots of calls, and so we're saving some bandwidth on signaling, so that's a great point. In this case, we're using the Tegace XMPP server, mostly due to the fact it has pub sub support, which is what we're using to send the information across the cluster. There's no reason we couldn't use other systems other than that they tend not to support the functionality that's required or the way that this has been programmed to allow that. The code could be modified to allow that, or if those servers added the functionality that Tegace gives us, then we could use those. So that's the main reason that that's the particular server you want to use. So yeah. So now we get into a really complex system where we have our calls coming in from the ITSP. Maybe this group of servers over on the left is where our PRIs are coming into and physical connections, and is all just for the phone system. Or maybe it's a proxy server or a group of proxy servers where you have your phones connected to and things like that as a registration. So that's essentially what that is. That distributes our calls down to our queue system. And the other thing is, maybe it's not a proxy over on the left-hand side there. Maybe they're all Asterisk systems, and they're adding the different functionality. Maybe we have conferencing boxes. Maybe we have, with using MeetMe. Maybe some are used for distributing our music on hold and things like that. We've started breaking Asterisk out into lots of different functionality, but we are routing calls down into each of these boxes that are handling queues. So the top ones are sales, the middle ones are support, the bottom ones for hardware returns and things like that. And then we distribute from there out to different Asterisk systems, which again are broken out and are just for each physical site, and all our phones are registered to that box. So with distributed device state, we can know, or the queue can know, what the state is of those phones at those remote locations to determine whether they should be sending calls to that particular person or not. So we're breaking out the functionality. So if one box can't handle all the queues or all the load for all the queues that we have, we can start breaking our queues out into multiple boxes and reducing that load. So this type of scenario with distributed device state allows us to start breaking things out into lots of physical systems. So there we go. So a couple of the issues that we could have in this type of a scenario is each system can be a queue, but we can't have multiple systems acting as a single queue because the queues don't have the ability to communicate essentially caller position. So let's say first caller comes into the first server, which is running our sales queue, and the next caller, number 2, comes onto a different server for the sales queue, the same queue. The first person here and the second person here, to those systems, just look like the first caller. So there's no way to stagger them and make sure that this person gets delivered before this person. It's just kind of a best effort at that point. The queues can sound the same, but they're not going to know the information between them to find out who should be delivered first. Maybe we don't care. Maybe the caller just hears the first person in the line, and this person hears like they're the first person in line. Do they know that someone else really got delivered before them? They're not going to know that. It's not like you're the first person in line. Well, not really. Someone else actually got delivered first. You're just still first person in line on that queue, and you're going to get delivered first off of that system. The only problem you might run into is if for some reason this queue keeps delivering calls faster because maybe this connection's a little slower and isn't getting the device state updated in time. So this person sits as the first person in line until essentially that queue is totally empty, which is obviously not what we want. Yeah, you could get into that type of situation too, where it just happens that both calls are delivered at the same time. So again, that's a problem that we could run into.
Could you actually just simulate a queue by putting them in the hold, you put them into the database, and you timestamp it, and you query the database, say which call is the oldest one, then you take them out of hold and you put them in the queue, there's the only one in the queue,
yep.
and they immediately distribute.
Yeah, you could do something like that where what he's basically saying is we're writing logging information into the queue and using that to determine essentially position. So we could use the local channel. We could look up that information in the database. Okay, should I really be going first? Did they get, essentially we're putting information in the database as a stack and we're popping things off the top. You could totally do that. The other thing is maybe you don't use queue at all. Maybe you are writing your own queuing system in an AGI and you distribute that way and using the AGI or fast AGI or whatever the case may be to keep track. Now obviously there's some development, there's a lot more work involved, but that's not to say you can't do it. Asterisk totally allows you to do that type of thing. So you can build in your entire queue system in Python if you want, build it outside of Asterisk, and then distribute that system or that script amongst your servers, have lots of physical servers, calls come in, runs in the script, sits in there, writes stuff to the database, or however you want to